What's up, guys? It's Mr. Brangle, and today we're going to be going over a VIRP chart for a parallel circuit. In a previous video, I covered a series circuit VIRP chart. I would definitely start there if you're looking at this for the first time, and then do this one second. So we're going to set this VIRP chart up the same way we did the previous one. We are going to put our total or our individual resistors on each of these rows here. So 1 ohms, 3 ohm, and 4 ohms. Now, I've set this one up to have the same value of the resistors as the series circuit so that we can see kind of the difference between the two, right? It's got the same battery voltage as well. Okay, so we have our totals here, or our givens. We want to go ahead and calculate our totals. We are always going to start, first step, calculating total resistance of the circuit. Now, we're going to do this quite different than we did for the parallel circuit. Total parallel resistance is 1 over, and then in the denominator here, it's 1 over the branch resistance for each branch individually. So 1 over R1 plus 1 over R2 plus 1 over R3, where R1, 2, and 3 are representative of the total branch resistance. Now, I've only put one resistor on each branch, so that makes it easy. Our calculation here will be 1 over 1 ohm plus 1 over 3 ohms plus 1 over 4 ohms here. And again, I'm going to be doing these calculations live. You should do it with me. Definitely check my work on this. Make sure you're getting the same thing. So in my calculator, I'm putting 1 divided by, and then I'm starting a parentheses, and then within the parentheses, obviously 1 over 1 is 1, but I'm going to go ahead and plug it in for the purpose of practicing. So 1 divided by 1 plus 1 divided by 3 plus 1 divided by 4, and then end your parentheses. You should get a resistance of 0.63157. Okay, so I'm going to write 0.63, I'll just go to 3 decimals here, 1 ohms. That would be the total resistance of this circuit here. So one way that you can sort of check your work on this is in a parallel circuit, the total resistance is always going to come out to be less than any one of your individual resistors. So our answer should have come out to be less than 1.0 since our smallest individual resistor was 1. And that did happen here. It doesn't necessarily mean that it's right, but it's at least leading us in the right direction. If our answer had come out to be more than 1, then we would know for sure it's wrong and we've done something incorrectly. Now, step 2 here is to calculate total current, which is always your second step regardless of the type of circuit you're looking at. Total current is going to be total voltage divided by total resistance, and in this case that's parallel resistance. So we're going to take that 9-volt battery and we're going to divide it by that total resistance that we just got, 0.631 ohms. Okay, so I did not delete that number out of my calculator. I left it in there so that I can get the true value. This is going to give me a total current of 14.25 amps. I'm going to go ahead and fill that in here, 14.25 amps. Okay, now the rule for current and voltage in a parallel circuit is opposite that of the series circuit. So in a series circuit, current is the same everywhere. That's not true in a parallel circuit. The current will get split up into the branches. When we add up the branches, they will add up to our total. So we're going to put that rule up here. It's going to add up to 14.25. Voltage, however, the rule is same. Now the caveat here is the battery voltage is applied to each branch. So the branch itself must drop 9 volts, and that'll be true for each branch. In this case, we only have one light bulb on each branch. So that means that each light bulb, according to the loop rule, is the first and the last resistor in the pathway must drop the full battery voltage. If we had more than one light bulb on a branch, then they would combine to drop 9 volts just like a series circuit. Okay, so the point I'm getting at here is that we know that each of these light bulbs must drop 9 volts. Has to, because each branch is its own individual loop back to the battery. And we have to have voltage drops that add up to be equal and opposite to the battery by the time we get through the very last resistor. So each one has to drop 9 volts here. Well, I'll go ahead and put that. So this was step 3 here, is V drops equal same. And you might just put that caveat across each branch. And then step 4 is to calculate current. And current is going to be found using this equation. We have to do this for each branch. So we'll have another A, B, and C. And we have to calculate the current going through this branch by taking voltage divided by the resistance in that branch. For this branch, we take the voltage drop across this branch and divide it by the resistance of the branch. Again, if we had multiple resistors in a branch, you would add them together for a total resistance value to figure out how much current's going through that branch. You could also take individual voltage drops divided by individual resistors. Anyway, this takes us to calculations here. So for step 4, I'm going to scoot over here and we'll kind of do like we did in the last video in A, B, and C. We'll call this one A, we'll call this one B, and we'll call this one C. So the current going through branch A is going to be equal to 9 volts divided by 1 ohm. The current going through branch B is going to be 9 volts divided by 3 ohms. And then I'm just going to move this up here for now. And then the current going through branch C is going to be 9 volts divided by 4 ohms. Okay, so obviously this is going to be 9 amps, this is going to be 3 amps, and 9 divided by 4 is 2.25 amps. Now, the thing is we just want to quickly make sure that when we add these together, that they come out to be 14.25, which, of course, they do. That's good. That means that we've done this correctly. So 9 amps, 3 amps, and 2.25 amps. Once again, we are not going to calculate power going through each, or power of each light bulb. Instead, we will do the total. So if that was step 4 right there, then step 5 is over here. And for power, it's always the same calculation. For this, step 6, power is equal to current times voltage. And of course, if we're doing total power, we want total current, total voltage. So that is going to be 14.25 amps of total current multiplied by the total voltage of 9 volts. And that's going to give us 128.25. And the unit of measurement is a watt. Very good. So that will conclude the VIRP chart for a parallel circuit. Obviously different than the series circuit VIRP chart. So make sure that you understand the rules for each circuit and why we're doing what we're doing, and make sure to ask questions if you do not understand. But that'll wrap things up here. Thanks for sticking with me, and I hope you learned something.